This is the frequently asked questions video for the Simplifying Roots worksheet. Starting with number 13, we can see that in number 13, we don't have any work to do in the denominator yet because the 5 is already simplified and there's no square root. However, the square root of 75 is something that we can simplify. So this will be 5 plus, and then you find the biggest perfect square to divide evenly into 75, and that will be 25, and that goes in 3 times. And then we can simplify that square root of 25 because it is a perfect square. That will be 5 square roots of 3 over 5. Now we have to look at this as a big fraction. And with fraction, the last step is always to figure out, can we simplify further? All 3 of these integers could have a 5 divided out evenly. So what we need to do is factor a 5 out of the numerator, because remember, canceling is a form of division, so we have to see multiplication before we can cancel. Now we have multiplication because we have that 5 times the quantity 1 plus the square root of 3, and these 5s will cancel out, leaving us with 1 plus the square root of 3 over 1, which is just 1 plus the square root of 3. So that is number 13. The next one to do. All right, number 19. 14 plus or minus the square root of 98 over 28. And we don't have a radical in the denominator, which is good. And this one confuses people because of the plus and minus symbol. What you want to do is just keep that one symbol as you work your way through, remembering that the quadratic formula has that plus or minus symbol in it. So what we have to do here is look at the square root of 98 and then find the largest perfect square that will divide into it evenly. And it turns out 49 will go in there 2 times. Then we'll simplify it to 4 plus or minus 7 square roots of 2 over 28. And we have to look at our 3 integers again. And 14, 7, and 28. A factor of 7 out of all of those. So we're going to factor that out of the numerator. And then it goes into 7 once and into 28 4 times. So we have 2 plus or minus the square root of 2 over 4 for number 19. And again, you just keep the symbol all the way through. So don't let that confuse you. The next one is number 22. And with this one, you can't help but look at it and say, well, 5 and 10, that will reduce. So what I'm going to do is make this one big fraction first, and then realize that 5/10 reduces to 1/2. Now we'll split it again, so that we can see, hey, the square root of 1 is 1, but the square root of 2 is the real problem, the real math that we have to do. And that's because we cannot call in the denominator. So what we do is multiply it by the square root of 2 on the top and bottom. Down here, we will now have the square root of 2 squared, which is just 2. And on the top, we have the square root of 2. And the square root of 2 cannot be simplified, so this is as simple as it gets right there. Square root of 2 over 2. The main point of this problem was we could simplify the fraction itself first, and then we had to rationalize the denominator. The next one, 5 plus the square root of 5 over the square root of 10. Well, with this one, the real issue is that there's a square root of 10 in the denominator. So just like in the last one, what we have to do is have 2 of those square roots of 10. And whatever we do to the bottom, we have to do to the top, because the square root of 10 squared is going to give us 10. But in the numerator, we will have to distribute the square root of 10, so it'll be 5 square roots of 10 plus the square root of 50. And hopefully when you saw the square root of 50, you said, oh, wait a second, 25 go into that. So 5 square root of 25 times the square root of 2. Trying to write with my finger and the 2's don't come out real well. So we have 5 square roots of 10 plus 5 square roots of 2 all divided by 10. And now when you look at the integer portions, what's in front of the roots and in the denominator, you see that a 5 could be factored out. So 5 times the quantity square root of 10 plus the square root of 2 all over 10. And then we can go ahead and divide by 5. So we're doing a little reducing there. And we'll have the square root of 10 plus the square root of 2 over 2. And you could write that as the square root of 2 plus the square root of 10 over 2. The order for the numerator doesn't make any difference. One was truly rationalizing the denominator. In that process, we ended up being able to simplify our numerator. Next up, square root of 2 plus 3 over 5 minus the square root of 2. So square root of 2 is simplified as much as it possibly can be. We are going to have to rational denominator, which means using the conjugate. Now the conjugate is what produces that sum and difference formula there on the bottom. But whatever we do to the numerator, we have to do to the denominator. Likewise, whatever we do to the denominator, we have to do to the numerator. So I'm going to make sure that my denominator works out first before I go back and worry about my numerator. And first times first is 25. But outside times outside is 5 square roots of 2, and inside times inside is minus 5 square roots of 2, and those cancel out. Last times last will be a negative square root of 4. And then your brain says, oh, that's 2. So we have 25 minus 2, which is going to give us a 23 in our denominator. That's a moment to celebrate and say, yes, I did something right. So using that conjugate gave us a nice integer. The numerator is a different story. This is going to be a little ugly. First times first, square root of 2 times 5 is 5 square roots of 2. Outside times outside, square root of 2 times square root of 2 is the square root of 4, which is kind of nice. Inside times inside is 3 times 5, which is 15. Last times last plus 3 square roots of 2. So then we notice, hey, or that's 2. And 2 plus 15 is 17. And 5 square roots of 2 can be added to 3 square roots of 2 because they're like radicals, so they both have a square root of 2. So plus 8 square roots of 2. And now I'm just writing that over the top of my 23 and checking to see, hey, out of all of my integers there, do I have anything that would factor out 17, 8, and 23? And nothing. 17 is prime, 23 is prime, so it is just 17 plus 8 over 23. Those are the FAQs for the Simplifying Square Roots worksheet.